Question 1 says, a culture of bacteria obeys the law of uninhibited growth. 500 bacteria are present initially and there are 800 after 1 hour. Write an expression for the number of bacteria, first of all in base 1.6. So we're choosing base 1.6 because that's the ratio change in 1 hour. So if I write the number as a function of time is equal to the initial number, so that's 500, and then I need to multiply that by 1.6 when the time is equal to 1 hour. So I'm just going to put the power of t up here. For this equation to work, we should probably note that this is t in hours. So if I wanted to write it in seconds, I'd need to divide the time in seconds by 3,600. So that would change it into a equation in seconds. But we'll probably leave it as a time in hours. So there's a kind of hidden divided by 1 in here. In base E, so the number at time t is still equal to the initial number, but now times e to the power of a constant times t. So we can see e to the power of a constant times t has to be equal to 1.6 to the power of t. Let's write that over here. E to the kt is equal to 1.6 to the power of t. So this I could write as e to the power of k to the power of t, and this I could write as 1.6 to the power of t. So I can take the tth root of both sides. So k is equal to the natural log of 1.6, which is 0.47. I'm just going to write it to two significant figures. So that gives me n as a function of t is equal to 500 times 0.47 t, again assuming t is in hours when I write it down. How many bacteria will be present in the culture after 5 hours? So I think it's probably easier to answer this question using the first form. We should be able to use either. So n is equal to 500 times 1.6 to the power of 5, or it could be equal to 500 times e to the power of 0.47 times 5. Whichever of those two we use, we should get the number present is 5,200. I'll write it to two significant figures. How long until there are 20,000 bacteria? So again, we should be able to use either form of the equation, but let's stick to the natural log, the e form, so that we can use a simpler log rule. So 500 e, so we know the value of nt now, don't we? So this is 20,000 is equal to 500 e to the 0.47 t. So on this side, we've got 200 over 5. We could do that, couldn't we? That's 40 is equal to e to the 0.47 t. Then we'll take the natural log of both sides. So the natural log of 40 is equal to 0.47 t. Up here, t is equal to ln 40 over 0.47, which gives us a time of 7.85 hours.